Okay, let's talk a little bit about simplifying radicals. So let's see what we got here. So kind of as a review, we want to find these square roots. So remember, 6 times 6 makes 36. So the square root of 36 is really plus 6 or minus 6. Notice that for number 2, they have plus minus square root of 144. That's going to give us plus and minus 12. This without a plus minus in front, we could look at that as just looking for what we call the principal square root, which is the positive square root, but always remember that there is a negative square root too. Here we want the minus the square root of 100 over 9. We can look at it as the square root of 100 over the square root of 9 with a negative sign out in front. Square root of 100 comes out as 10. Square root of 9 comes out as 3. And we got our negative sign out in front, so negative 10/3. Here we want the principal square root of 36 over 169. That's square root of 36 over square root of 169. Times tables helps here. Square root of 36 is 6. Square root of 169 is 13. And these don't simplify. Let's look at the vocabulary. So radicals indicated root of a quantity. Usually we talk about square roots. If you see another little index number here, like a 3, we're talking about a cube root, or 4 would be a fourth root, and so on. Fourth root would be something like sometimes itself 4 times that makes the number would be a fourth root. Square root something times itself twice. So let's look at number 5. So this expression is a radical expression. That's true. The radical expression is in simplified form. That's not true because the square root of 121 is 11. So 11 is a simplified form for the square root of 121. 5 root 7, 5 square root of 7 is in simplified form. Neither one of these can be broken down anymore. That's a true. The radicand in the radical expression, that's what's inside the radical. It's not 5, but it's 7. That's false. And the radical expression is in simplified form. This is not considered simplified form because it's got the root in the bottom. We do a process called rationalizing the denominator by multiplying by whatever would cause the denominator to be a whole number, which is another root 3. And we do top and bottom times that, so we end up with 5 root 3 over 3. So even though it looks more complicated, this is considered simplified form because it doesn't have a radical in the denominator. Multiplication property square roots, we multiply what's inside the same type square roots, so square roots go with square roots. So let's see what we got here. Square root of 98 is the same thing as the square root of 49 times 2. And we can do square root of 49 comes out as a 7. So we have a 7 square root of 2 in simplified form. Square root of 200 is 100 times root 2. And we can take the square root of 100 out as a 10. And we're left with the root 2. So 10 root 2 is a simplified form. And square root of 28 is not 4 times the square root of 7. It's actually the square root of 4 times the square root of 7. So that's the one that's not correct. Moving variable factors. So a lot of times when you have a number like 80, you want to find the biggest perfect square that goes into 80. So I'm thinking about like 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. That's about as far as you need to go. You got 100 out here for the 10 times 10. And 16 times 5 makes 80. Which is going to be this one. So we could look at the square root of 80 as being the square root of 16 times the square root of 5. And the square root of 16 comes out as a 4. So we end up with 4 square root of 5 as the simplest form for square root of 80. So, number 12, search the expression that should be used to simplify this. So we're looking for something that's going to break this down in the center. Now, rules of exponents, if I have an m to the fourth times an m to the fourth, we add the exponents, we get an m to the eighth. So the square root of m to the eighth is going to be m to the fourth, because m to the fourth times m to the fourth made m to the eighth. So we're kind of taking out even powers here. So if we look at this 9 here, we could actually look at this as 16 times 5, m to the fourth times m to the fourth times an extra odd m to the first. And we got the minus m outside the square root. So we can take the, let's see, so what did they do here? So we got m to the fourth, which is the m to the eighth, times a single m. They got the 16 with the m to the eighth, so the 16 can be factored out, or take the square root of 16 is going to be a 4. Square root of m to the eighth is going to come out as an m to the fourth. So this is the one that's going to serve to simplify that expression. And they want us to actually simplify this. So we've got minus m square root of 16 m to the eighth times the square root of 5m. So the 5 times the 16 gives us the 80. The m times m to the eighth gives us the m to the ninth. It's the square root of 16m to the eighth comes out as a 4m to the fourth. We've got a minus m out in front, and we're left with 5m kind of stuck inside the square root sign. And outside here, this m times m to the fourth makes an m to the fifth, so we end up with a negative 4m to the fifth square root of 5m. And that's the simplest form. Let's see what we got here. Multiplying two radical expressions. Complete the missing model below. Let's see what we need to do. Complete the reasoning model below. You think I need to multiply the radicals first. So you might want to do 6 times 18. 6 times 10 is 60, and 6 times 8 is 48. So that'd be 3 square root of 108. To simplify the radical, I first need to think of the biggest perfect square of 108. Then I would use the multiplication property of square roots. So let's see, 108. If I kind of do a factor tree with 108, we got 2 times 54, which is 2 times 27, which is 3 times 3. So 27 is a perfect square. And that might be the biggest one we have. We might also have 4 here. 4 times 27 is going to be the 108. So we can think of this as 3 times 4, or 3 times... So we end up with 3 times square root of 27 times the square root of 4. I'm not sure what's going on in this part here. Square root of 27. Well, that's not the biggest perfect square. That's a 9 is the biggest perfect square. Okay, so back up here, man. Okay, so I started looking at this wrong. So we got, we want to simplify 3 root 6 times root 18. So that gives us 3 root 108, because we can multiply what's inside the square root together. And 108 is actually 3 times 36. And 36 comes out as, so that gives us 3 times the square root of 3 times the square root of 36. The 36 square root comes out as a 6, and we're left with the 3 inside the radical. So then we get 18 square root of 3 as our final simplified answer.